Hello students, in our previous video we had discussed about Haber's process, that is the large scale preparation of ammonia. Today we will go on basically to the physical properties of ammonia. Before we start the physical properties, just recapitulate how we prepared hydrochloric acid from hydrogen chloride gas. So hydrogen chloride we prepared in the laboratory, and if we wanted hydrochloric acid, then what did we do? We dissolved the hydrogen chloride gas in water. Similarly, after preparing ammonia gas, if we want ammonia solution for a particular experiment in the laboratory or something like that, how do we make liquid ammonia? Not liquid ammonia, solution of ammonia. How will we make? We will again dissolve this ammonia in water. And how do we do that? What is the special arrangement that we are going to use? So just similar to hydrochloric acid, the same apparatus setup that we had there, we are going to use here. Yes. So when ammonium chloride and calcium hydroxide react, ammonia gas is liberated. That ammonia gas is led through the delivery tube into a trough containing water. If we do this, then what will happen? What may happen? The result will be that the ammonia gas, all the ammonia gas that is present in the delivery tube will quickly dissolve in water, because ammonia is highly soluble in water. So what will happen? Quickly dissolve, and then the manufacture, that is the preparation of ammonia, will take time in the round bottom flask. So what will happen? For the time being, you will see that a partial vacuum is created in the delivery tube. Due to that partial vacuum, what may happen? Water may be sucked in to equalize the pressure, and the water may even reach the round bottom flask, which is hot. Which may lead to cracking of the apparatus. So, in order to avoid that, what do? Yes, we use a special arrangement, and what is that called? Inverted funnel arrangement. Yes, you are right. And just as we saw in hydrochloric acid, here also we are going to do the same arrangement, and we take an inverted funnel. And how do we keep the funnel? Submerged in water? No, we don't keep like this. Yes, we only allow the mouth of the funnel, that is this part, to be touching the surface of water. Now what will happen is, the ammonia gas that comes from the delivery tube, that is ammonia gas which is prepared by reacting ammonium chloride and calcium hydroxide, will come through the delivery tube and it will dissolve in water, and this funnel here provides a large surface area for absorption of the gas in water. Yes, compared to the delivery tube, which has only a very small cross-sectional area it had. But now the funnel has more cross-sectional area, so it will allow more rapid absorption of the gas in water. So the gas will dissolve in water. A partial vacuum will be created in the funnel and the delivery tube. The water will be sucked up. When the water is sucked up, then what will happen? The volume of the funnel now is more than the delivery tube initially we had. So the funnel will absorb water. It will pull up, suck the water up, And when the funnel sucks that much of water, then what will happen to the level of the water level, the surface of water will go down. The surface of water which was here earlier, now when the water is sucked up, it will go down. And when the water level goes down, then what will happen? The funnel has lost contact with the surface of water. The funnel loses contact with the surface of water. Again, what will happen? Due to gravity, the water will be pulled down. Okay, the water which is sucked up will be pulled down. Again, when the water falls down, the funnel will again come in contact with the surface of water, and so on. The procedure will go on. That is, as the ammonia gas is prepared in this round bottom flask, ammonia will come, dissolve, and a partial vacuum will be created. The water will be sucked up, but the water will not, so much of water will not be sucked up that it will reach the round bottom flask. It will only be inside the funnel here, because now the funnel has more volume, more capacity. Okay, so this is the procedure of making ammonia solution. Okay, so now we move ahead again to something that you have already done in hydrochloric acid chapter. Let us go on to the physical properties of ammonia. Physical properties of ammonia. In the physical properties, you will go through all the physical properties, but a few are mentioned in your syllabus, like density. What can you say about the density of ammonia? Ammonia is lighter than air. Ammonia is lighter than air. Then you can talk about what is the smell, what is the color of ammonia? Colorless. What is the smell? Pungent, choking smell. Pungent, choking smell, ammonia. And what can you say about the solubility of the gas? Like hydrogen chloride, ammonia is also very highly soluble in water. And to demonstrate the high solubility of hydrogen chloride in water, we used the fountain experiment. Similarly, here too, we will use the fountain experiment for demonstrating the high solubility of ammonia in water. The setup will be the same, only there will be slight differences. Let us see what are the differences. We have an inverted round bottom flask. Okay. In the round bottom flask, in the cork of this round bottom flask, we have a dropper. We have a jet tube. Jet tube means what, children? A tube which is open on both the ends. Okay? A tube which is open on both the ends. Here we have red litmus solution. Red litmus solution. Here we have ammonia gas. Here inside this rubber glass dropper we have water. Okay, this was the setup even in hydrogen chloride, you saw that. And now we have a similar setup. In hydrogen chloride, we took hydrogen chloride gas here in the round bottom flask. We took blue litmus in the trough. Now we are taking ammonia gas in the round bottom flask, and we are taking red litmus solution in the trough. All the rest of the things are similar to what we did in hydrogen chloride gas. Now, what is our first step? Our first step is to press this, the rubber part of this water dropper, and when we press it, a few drops of water will fall. Not many drops, a few drops, because it is a small dropper. A few drops will fall, and in that few drops of water, what will happen? Ammonia being highly soluble in water, the ammonia gas present in this round bottom flask will dissolve. It will dissolve and it will create a partial vacuum here. It will create a partial vacuum. So this, because of a partial vacuum created, a low pressure area created here due to the dissolution of ammonia in water, what will happen? To equalize the pressure, the red litmus solution will be sucked into the round bottom flask. Now when the red litmus solution moves from the trough into the round bottom flask, it will no longer be red. Why won't it be red? Because inside this round bottom flask, a good amount of ammonia has already dissolved in a few drops of water, but there is still some ammonia left there. So that ammonia will turn the red litmus solution into blue, showing the alkaline nature of ammonia gas. So what will happen? The red litmus will be sucked up, but inside the round bottom flask we will see the red litmus solution as a blue fountain. We will see as a blue fountain. We will see blue fountain. Why blue fountain? Because showing the alkaline nature of ammonia. Alkaline nature of ammonia. So what does this experiment, the blue fountain experiment, we call it, to specifically we call it the blue fountain experiment. What does this blue fountain experiment demonstrate? The blue fountain experiment demonstrates the high solubility of ammonia gas in water, not the alkaline nature of ammonia. Had ammonia not been soluble in water, this ammonia gas would never have turned the red litmus solution into blue. So which property of ammonia is being demonstrated by the blue fountain experiment? High solubility of ammonia in water. Okay, so this is the experimental setup. You are supposed to know very well. It is specifically mentioned in your further reduced syllabus of ICSE 2021 examination. So please learn it nicely, thoroughly. Compare and learn. In HCl, we call it the red fountain experiment. In ammonia, we call it the blue fountain experiment. What is the difference? There we take blue litmus solution in the trough. Here we are taking red litmus solution in the trough. There we are taking hydrogen chloride gas in the inverted round bottom flask. Here we are taking ammonia gas in the round bottom flask. There we see a red fountain because HCl gas is acidic and will turn blue litmus into red. Here we see a blue fountain because ammonia gas is alkaline in nature. Once it dissolves, in the gaseous state it is neutral, but once it dissolves in the solution, it is alkaline in nature and it will turn the red litmus solution into blue. So that is it today, children. Please go through the physical properties well and learn the physical properties as well as the method, as the special arrangement we use for making ammonia solution.